Looking at the Spike output, the core ID is displayed in the first column. This is the core ID of the core that is executing the instruction. This is followed by the PC, the opcode, and the instruction mnemonic. Since Spike was run with the -log commit switch, it also displays the architectural register state at the completion of that instruction. The current privilege level at which the instruction executed is also shown. Here, a privilege level of 3 means the instruction execution happened in machine mode. Spike begins execution at its built-in ROM entry point, which is at address 1000. Here, it executes minimal machine code before transferring control to the test program, which begins at PC 8000000. At this point, the core is still in machine mode and the test begins its initialization sequence. One of the first actions in the test is configuring the trap handler. The program writes the base address of the handler, which is 8000048, into the empty vec CSR using the CSR write instruction. It also clears the emidelig CSR. Next, the test deliberately triggers an exception by executing the ecall instruction while in machine mode. Because the exception originates in machine mode, the trap is handled horizontally. That is, the privilege level does not change. Inside the handler, the code reads the mcos CSR, which reports a value of B, identifying the exception as a machine mode environment call. The handler also reads the MEPC CSR, which gives the PC of the instruction that triggered the exception. After capturing this information, the handler jumps to the test end section. In the test end, there is a write of 1 to the to-host memory location. This is used to signal to Spike that the test has completed successfully. Following the write is the illegal instruction that we added to the source, which forces the evaluation of the to-host memory location. At this point, when Spike evaluates the to-host memory location and sees the test completion code, it terminates the test.